These are 5 circuit diagram questions. Class 10, solved. Exactly the kind of circuit diagram questions Class 10 physics loves to ask, and right now the answers are on screen with real numbers on a live circuit. Look, 12 volts here, 6 volts there, a real current flowing around the loop. That's not a guess. That's a simulation proving the maths. Stick with me, and we'll work through all 5. Draw the correct circuit, do the calculation, and where it helps, run it live to check the answer. 5 questions, 5 clean marks. Question 1, the easy mark. Draw a simple circuit with a cell, a switch, and a bulb, using the correct symbols. Get the symbols right, and this is free. Start with the cell on the left. 2 lines, 1 long, 1 short. The long line is positive, the short line is negative. Add the switch, 2 dots, and a little lever. Open means a gap. Closed means current flows. Then the lamp, a circle with a cross inside. Join them with straight wires into one closed loop and mark the current with an arrow from the positive terminal. Round through the switch and the bulb and back to negative. Cell, switch, bulb. 1 loop, correct symbols. In an exam, those symbols and that current arrow are the marks. Question 1 done. Quick heads up before question 2. Every circuit in this video is drawn in Circuit Diagram Maker, a free website that runs right in your browser. No download, no sign up. Open it in a second tab, and you can build and simulate each of these questions yourself. The link is below. Question 2, a series circuit. 3 resistors, 4 ohms, 6 ohms, and 10 ohms in a line with a 12-volt battery. Find the total resistance and the current. In series, there's only one path, so the resistances simply add up. Total R equals R1 plus, R2 plus, R3, 4 plus 6 plus 10, which is 20 ohms. That's your total resistance. Now the current. Ohm's law. I equals V over R. 12 volts divided by 20 ohms gives 0.6 amps, 600 milliamps. And here's the exam habit that wins marks. In a series circuit, the current is the same everywhere. That same 0.6 amps flows through all 3 resistors. Question 2, total resistance 20 ohms, current 0.6 amps. Question 3, the one that catches people out, a parallel circuit. 2 resistors, both 6 ohms, connected across the same 12-volt supply. Find the total resistance, then the current in each branch. For parallel, you add the reciprocals. 1 over R total equals 1 over R1 plus 1 over R2, 1 over 6 plus 1 over 6, which is 2 over 6, or 1 over 3. Flip it back, and the total resistance is 3 ohms. Notice that's smaller than either resistor. That's the rule for parallel. The combined resistance is always less than the smallest branch. Now each branch feels the full 12 volts, because in parallel, every branch sits straight across the supply. So each branch current is V over R, 12 over 6, 2 amps. 2 branches, 2 amps each, for amps total from the battery. And check it, 12 volts over the 3 ohm total is 4 amps. It agrees. Question 3, sorted. Question 4, apply Ohm's law to find an unknown, and then let's prove it live. A resistor carries a current of 0.6 milliamps when 6 volts sits across it. What's its resistance? R equals V over I. 6 volts over 0.6 milliamps, which is 10,000 ohms, 10 kilo ohms. Now, let's not just trust the maths. Let's run it. Here's a real series circuit in the free editor. A 12-volt source with 2 10 kilo ohm resistors. I press Simulate. Choose DC operating point and run. And look, the real numbers land right on the diagram. 12 volts at the top, 6 volts at the middle node, 0 at the bottom, and a current of about 600 microamps flowing around the loop. The software solved Ohm's law for us. 12 volts across 20,000 ohms gives that 600 microamp current, and 6 volts across each 10 kilo ohm resistor. Exactly what the formula predicted. That's how you check a Class 10 answer. Build it and simulate it. Question 5, the classic. Where do you connect an ammeter and a voltmeter, and what does each one read? Get the placement right, and you own this question. The ammeter measures current, so it goes in series, right in the loop, in line with the resistor, so the same current flows through it. To add one, you break the loop and slot it in. An ideal ammeter has almost zero resistance, so it doesn't change the current it's measuring. The voltmeter measures voltage across a component, so it goes in parallel, clipped across the two ends of the resistor, side by side. You never break the loop for a voltmeter. An ideal voltmeter has very high resistance, so almost no current leaks through it. Ammeter in series, voltmeter in parallel. Read the ammeter for current, read the voltmeter for voltage, and you can prove Ohm's law on the bench. Question 5 done. So there are your 5 circuit diagram questions, Class 10, all solved. Question 1, a cell, switch, and bulb in one loop with the correct symbols. Question 2, series resistances add, total 20 ohms, current 0.6 amps everywhere. Question 3, parallel adds reciprocals, total 3 ohms, 2 amps in each branch. Question 4, Ohm's law gives 10 kilo ohms, and the simulation confirmed it. Question 5, ammeter in series, voltmeter in parallel. 2 habits when the easy marks across all of them. Check your units before you calculate. Convert milliamps and kilo ohms first, and draw every circuit with the correct symbols and a current arrow. Keep a symbol chart open while you revise. Every symbol you need is on one page, ready to copy. That's the full set. 5 circuit diagram questions for Class 10, drawn, solved, and checked against a real simulation. Series resistances add, parallel resistances add as reciprocals and come out smaller. Ohm's law, V equals I times R, ties them all together. Ammeter in series, voltmeter in parallel. Now do it yourself. Open Circuit Diagram Maker, build each circuit, press Simulate, and watch the real voltage and current appear. It's free, it runs in your browser, and the link is right below. Always follow your teacher's lab safety rules. Subscribe if this made Class 10 electricity finally click, and good luck in your exam.